Hello, my name is Jonathan Osborne, and I'm Professor of Science Education here in the Graduate School of Education at Stanford University, where I've been for 7 years. In this video, I'm going to explain some of the thinking behind why we would like to argue that engaging students in argumentation in science education is an important activity, both for helping them developing an understanding of the nature of science and to help their learning. Our argument's really based on this figure. It's figure 3.1, page 45, in the framework for K-12 science education. What it does is it illustrates that scientists engage in really three realms or spheres of activity. On the left-hand side, you have the investigation space. And this is the kind of activity that typically most people think that this is what science is about. It's about sticking instruments into things, doing observations, or doing experiments and finding out things. We think that that's a bit simplistic, because actually what really matters in science is the development of theories and models. If I asked you to think of a famous scientist, I'd guarantee that 90% of you would think of a name that's associated with theory, such as Darwin or Einstein, people like that. It's much harder to think of somebody who's famous for an experiment they did. This is because fundamentally science is about ideas. But those ideas have to be argued for, in that sense. Because lots of us can have ideas, and in some senses the history of science is a history of flawed ideas. As the historian Alistair Crombie argued, the history of science in the European tradition is the history of vision, i.e. having of ideas, and argument to ensure that those are successful. Now, our definition of scientific argumentation is essentially a process of using evidence and reasoning to determine which of the competing ideas about the natural world are best, or is best, I should say. Argumentation involves a process both of construction and critique. Construction is the process of building or assembling the idea, and critique is the process of holding it up the light to see if it withstands the test of evidence. The argument we make, essentially, is that knowing why you are wrong matters as much as knowing why you are right. If students can explain why an idea is flawed, and why the right idea is better, then they're much more likely to have a secure understanding of the scientific concept. The issue you face, in that sense, as a science teacher, is it's important to engage students in scientific argumentation, because many of the ideas that you're actually asking them to believe in are somewhat crazy ideas. Here's, for instance, a few of them. Day and night is caused by a spinning earth rather than a moving sun. Continents can actually move. We live at the bottom of a sea of air. In the absence of friction, things keep going forever. Now, I have a much longer list than that, but you start to think about it. As a teacher of science, these are the kinds of things you're asking your students to believe. If that's so, we need to give you the evidence that justifies those kinds of belief. Now, our argumentation assessments are informed by a few other principles that I've not yet discussed. First of these, clearly, is that scientific argument does depend on knowledge. If students understand what they're being asked to argue about, then really it's going to be very difficult for them to engage in that process of arguing. Now, for instance, just imagine trying to ask people to engage in an argument about quantum mechanics when you know nothing about quantum mechanics. Second thing is that argumentation is in some senses a dialogic process. It requires you to engage with others. Now, obviously in an assessment item you can't do that because you're doing it on an individual basis, but we always set up our scenarios so that there's a dialogue where there are two ideas that have to be considered, so you at least have to engage in an argument with yourself. Last thing is argumentation is essentially premised on uncertainty. If the meaning of the data is ambiguous, or if the idea is unambiguous, then there's little to argue about. So there has to be something there's some difference, some point of contention, which students can resolve by engaging in argumentation. We encourage to keep these ideas in mind as you teach and assess scientific argumentation, and we hope that you find this website useful.